Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 342, I chat with Peter Madnick, the chief alchemist at Audio Alchemy, about all things audio. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by CacheFly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded February 23rd, 2017. Episode 342, The Audio Alchemist. This episode of Home Theater Geeks is brought to you by Grasshopper. Stay connected and run your business from your mobile phone with Grasshopper. To save $50 on your order, visit trygrasshopper.com/twit. Hey there, Scott Wilkinson here, the home theater geek and editor of avsforum.com. This week's guest geek is Peter Madnick, the chief alchemist at Audio Alchemy. Hey, Peter, welcome to the show.
Hey, Scott, thanks for having me.
Oh, thank you for being here. Before we get started, I want to make sure those who are watching live at live.twit.tv can know that you can join the chat room there or at irc.twit.tv. And you can post questions as we go, and I'll pass along as many as I can. Always helps if you put my screen name in the message, my name, Scott Wilkinson, no dots or dashes, because then it shows up in a different color and I can see it more easily. Also want to let you know, let all Twit fans know, that we want to hear from you in our new audience survey. It should only take a couple minutes to finish, and it will give us a general idea of what kind of programming you want and what kind of advertisers you'd like to hear from. Of course, we take privacy very seriously here, and I'm sure you do as well. And we want to make sure that you know that we promise to protect that at all times. We do not identify you in any way in the survey. So head on over to twit.tv/survey now. Well, after the show, say. And we thank you very much for your input. Helps us out a lot. Okay, so I'm talking with Peter Madnick, who you've been in the audio-video business quite a long time, haven't you?
Yeah, I think I started when I was 14, so I'm almost 60.
So, yeah, a few decades.
Yeah, most of my life.
Yep. I imagine you must have started in retail, as many of us did.
Yeah, I was fortunate to have a friend that was a couple of years older than me that had a job at a Radio Shack store. And in those days, Radio Shack sold all kinds of audio equipment. And
I remember those days well.
Yeah, and they needed somebody to put turntables together. So my life started as a turntable assembly and repair person.
Huh. Wow. But then you ended up, getting more education and starting to design stuff, right?
Yeah, I worked my way through kind of the big retail chain store in the Massachusetts area called Tech Hi-Fi. Did 3 or 4 years there, and then was one of the founders of Natural Sound in Framingham, Massachusetts, which was a high-end audio store that started at Worcester Polytech University, where I attended with a couple of guys, one named Jim Lackey and one named Kevin Vakes.
Oh, of course, Kevin Vakes.
Right.
We know him. He's a friend of the show, yes. No question.
Right. So we had a retail store, and that's where my real love of high-end audio started. And that's where Kevin used as a launching point to go off and do his loudspeaker designing. Mm-hmm. And I used that as a launching point to go to a company called Denison Electrostatics, which sounds like a speaker company and certainly did make electrostatic loudspeakers. But I think we were famous for something we did a couple years after I joined called the Sound Tractor, which was a phono-cartridge alignment device, which I think you have a picture of there.
I think we do, called the Sound Tractor. Let's see if we can take a look at that. There it is. Tell us what we're looking at here. That looks pretty strange.
Yeah, so that was a fixture that you used to, you centered it over the pivot point of your tone arm Obviously, it sat on the spindle, and it put a little crosshatch area and a dot where the stylus should be in order to properly align the cartridge to the bare-walled formulas. It was very simple to use. It uses some very elegant geometric tricks that just made the whole thing work really simply. And we kind of became the standard and the only cartridge alignment device other than a piece of paper with crosshatches on it and a 2-point alignment system. And that really became a very popular product. We sold many, many, many thousands of them. And
so you sold those to end users to align their cartridges.
That's correct. And we were fortunate to have like Doug Sachs Sheffield Records suggested them to people, as did many other record companies in the audiophile world, Crystal Clear, people like that. And we really made quite a name. And frankly, I think, helped start an industry because, of course, cartridge alignment devices became a big deal after that. Many of them violating the patent that myself and my partners had in place. Yeah, just that was life.
Yeah. Okay. All right. Well, certainly in these days of vinyl resurgence, the need for such a thing is probably greater than ever.
Yeah, and there, of course, now there are a lot of them. The Fikert, the Wally Tractor. There's many others that kind of look like that one. Our patent's long since expired. So, yeah, there's many twists on a similar thing now.
Mm-hmm. Now, interestingly, I found this very interesting that you also worked on video stuff. So it's not just audio.
Yeah, I mean, that came a little later. After the first Audio Alchemy had closed. Just before we closed that company, we had a video product called VRE, which was a all-digital comb filter that, of course, separated composite video into S-video. And that came to the attention of Sam Runco at Runco Video, and that led to him, first of all, picking up some of my former engineers because he needed guys. And secondly, us then getting together with Sam and creating a line of scaler products, projectors, and plasma TVs. And that lasted, 7, well, if you include the time that they were acquired by Planar, almost 9 years.
Oh, wow. So you continued to work for Runco after the Planar acquisition?
After the Planar, until Planar decided to replace all of the products that had been developed in the Runco days with things that they had either sourced or developed themselves.
I gotcha. Okay. So Audio Alchemy, which is, we're going to talk more about Audio Alchemy in this show, but I hadn't realized that you had started it and then it went away and then came back, I presume.
Yes. So back in the days, I guess late 80s, we formed the company basically on a shoestring. We made a name for ourselves with some very inexpensive DDA converter products. We are credited by many as having discovered jitter, although obviously jitter was always there. All we did was make a product that addressed it at a reasonable price. And we kind of set, I think, a pretty high bar for value, making people understand that digital really can be very good and doesn't have to cost a lot more money than good CD players of the day. You just have to have the right product.
Mm-hmm. Mm-hmm. A couple questions in the chat room about aligning phono-cartridges. Tinkertoy Tech is mentioning that make sure your cartridge is in alignment to a math curve that they record to. Bleak was asking, in what way? How does it what does it mean to be properly or improperly aligned?
So there are, if you look at how a tone arm traces a record, it goes in an arc, and the angle of that arc is related to how long the arm is. And there is a there are a number of mathematical formulas that determine where the optimum location for either lowest average distortion across the album or lowest distortion at the beginning or lowest distortion at the end, etc.
You have to make that choice. I find that interesting.
Yeah, so there was a lot of work done in the 20s, 30s, 40s to work out the math for what seemed to work for most people, and that would be lowest average distortion across the whole album, and that would typically be the Baerwald formulas. That was the name of them, and that's what we developed to, and that's the typical 2-point alignment system that a lot of tonearms come with, turntables come with these days. There's a spot, I think it was 2.6 inches and one at 4.76 inches, that are the two places where, as the arc transcribes the record, it will be perpendicular to the radius and therefore have zero tracking angle error.
Which, of course, when you have a regular tone arm that moves on a pivot, that angle will only be achieved in one place, not across the whole record.
Right. Well, you can make it be achieved at two places if you put the arc in the right location, and that's what our device did. And it's really why we developed a product to do straight line tracking. In fact, I think I gave you a picture of that you could put up, called the ABLT. At Denison, we made an arm that didn't have any tracking error. And there were other, this guy right here. There were other straight line, there were other straight line tracking arms at the time, but they all had servo motors, and ours was an air bearing and essentially zero friction, and therefore didn't need any external motors or forces to move the arm along the record.
Loquacious in the chat room is saying, reminds me of the Rabco linear tracking tone arm.
Right. The difference, of course, that Rabco had servo motors. So there were little micro switches that would get flipped, and a little motor would turn on and move the arm along. This actually didn't need any of that because there was no bearing friction.
Right. So did the arm move? Did the record actually cause the arm to move as the cartridge was in the groove? Yeah. Yep. Okay. That makes a lot of sense. Of course, an air bearing means that there has to be a fan or an air pump or something in there, and wouldn't that cause some noise? Yeah,
you had to hide it. You know, you'd put it a room or two away in a long hose.
But still, you've got little jets, I assume, that cushion the actual thing that's resting on the cross piece. Wouldn't that cause some noise, or not significant?
There was a little row of holes about 10,000ths of an inch in diameter, and you had to run the pressure low enough that you didn't get turbulent airflow through the holes, so they wouldn't whistle. As long as you did that, it was very, very quiet.
Okay. Dr. Morbius is asking, seriously, is this worth it?
Well, you know the statement, beauty is in the eye of the beholder. There's a similar one. There's a similar one for audio.
Yep. Sound is in the ear of the beholder.
That's right.
Okay. Well, we're gonna talk a little bit more about that later. But I wanted to also mention you've had your fingers in so many audio video pies. One of them being Constellation Audio, which is I guess at the other end of the price spectrum. Audio Alchemy, as you mentioned earlier, has always been known for value, high quality products that don't cost a lot. Constellation Audio, on the other hand, is known for high quality products that cost a heck of a lot.
Right. Yeah, Scott, we've probably done, it's well over 400 consumer products in the 40 years approximately that I've run my development company. And I think that, it's the accumulated knowledge of all of that, and some very, very good friends I have in this industry who are, some of the best designers in the world, that allowed us to develop the Constellation Audio line for the Australian company that owns the brand, and really, push what is possible in analog engineering these days. And
well,
it unfortunately costs a bunch of money.
Yeah. Well, this is one of the things I really wanted to dig in with you about is analog versus digital. Now, I've always said that analog electronics, well, let me put it this way. Digital electronics can be high quality and not very expensive, because once you design a chip that's really good, or design a circuit with a series of chips on it that performs well, you can stamp out 1 million of them and it doesn't cost you that much. Whereas analog electronics are always going to be expensive for high quality analog electronics. Do you agree?
Yeah, I mean, it is a problem. If you tried to compare apples to apples there, yeah. I mean, we don't do exactly the same things, so therefore the kind of parts you use are different. Mm-hmm. The bigger problem we're having on the analog side is that a lot of the manufacturers of semiconductors that we have all used for decades are no longer making parts that we want to or can use.
Really?
There's just not enough volume or profit, I guess, in taking a piece of silicon and making a transistor you can sell for $1 if you can instead make a chip that you can sell for $10. And unfortunately, the need or the use of these parts doesn't demand the level of investment that it takes to make them. So as analog uses disappear, the parts that we need to make analog products disappear as well.
Oh, man. But is the need or the desire for analog really disappearing? I mean, certainly digital is probably the predominant technology with cell phones and so on and so forth, all the different types of products. But there's still an active audiophile community out there, as evidenced by the fact that the Perfect Vision, the Absolute Sound and Stereophile are magazines that are still going strong after decades. They're still going strong. And so there must be people out there who still want this stuff. It's just not a large enough pool to entice manufacturers to keep making audiophile quality FETs and so on.
There are certainly boutique manufacturers of semiconductors now that have cropped up or who have decided to look at this market and have assumed it's viable enough to make parts for. But you take a big company, Texas Instruments or somebody like that, the audiophile world doesn't represent a tiny, tiny fraction of what they would need to make it worth making a part. I would suppose Analog Devices might argue with that. They're making fabulously good op amps, for example, or I guess TI as well. But there's other uses that drive it, not just hi-fi.
Mm-hmm. Yeah, true enough. I would imagine. I mean, Analog Devices is a huge semiconductor manufacturer, and what an interesting name of the company, Analog Devices. They have to still make analog devices.
Of course, yeah. But they make things like DACs, for example, and op amps. But I think more what I'm referring to is the availability of discrete semiconductors like FETs and transistors. There's just way less than there has been before. And for a line like Constellation, we've actually had to buy new old stock like people were doing with vacuum tubes 10 years ago before more manufacturers started to make them again. And hopefully that will happen at some point with semiconductors as well.
Mm-hmm. Well, I was going to ask you about tubes, vacuum tubes, which, as you say, they fell pretty far out of favor, not out of favor, but just not used very much. And yet there is, again, a small but dedicated community of people who really like the sound. And I guess now there are some companies. It used to be, I remember, 10 years ago or so, the only place you could get vacuum tubes was from Russia. Mm-hmm. And I guess that's no longer the case. There are some people now making tubes again.
Yeah,
people?
there's a resurgence in tube manufacturing. Relative to making a transistor, a tube is easy. There's equipment you can buy that will let you evacuate the air and assemble little bits and pieces. And there are companies that make tubes, little small startups, and they're
Isn't
all
that
over
funny?
the world. Yeah,
I would have thought that tubes would be harder to make. A transistor is just a little chip of silicon. You need to manufacture in a certain way, but it seems to me that would be easier. But I guess not, huh?
no, the photolithography to make a transistor, it's pretty tough. Etching away all the silicon and putting all the dopants and oxides on. Need a lot of equipment.
Right. Well, what's your feeling of say, let's talk about tubes versus transistors in analog components? What's your feeling about how each one sounds?
Difficult subject, Scott,
Hey, I ask the hard questions on this show.
You do. I, of course, have heard both sound amazingly good and both sound amazingly bad. And, there's a lot to the topology of good sounding tube and transistor circuitry. You can use FETs, for example, and MOSFETs and make things that are tube-like and vice versa. And sometimes they're successful and sometimes they're not. And there's guys that are really, really good at it. Guys and gals, actually, some really good engineers who can make tubes sound great. And there's some that can make solid state stuff sound great. And unfortunately, not everybody's successful with it each time they try.
And so the reputation of the technology might be based more on the ability of the designer than on the technology itself.
Sure. I mean, we can all cite companies who have had, a fabulous run of great products of a particular type, let's say all tube, and then there's one that isn't so good, and they may follow it up with a better one or a worse one, or it just comes down to paying attention to all the details and making sure, I's and T's are dotted and crossed, and maybe you go back to some earlier thoughts that worked and develop them more rather than going off on some other direction.
Sandman in the chat room is saying Nelson Pass of Pass Labs has been buying up discontinued parts, much like Constellation has, I guess.
Yeah. There are a few of us that have been seeking some of the same parts, in fact.
Yeah, right. I'm now imagining, a Black Friday sale where Nelson Pass and you and some other people are fighting over the last remaining transistors.
Right. Little bidding wars here and there. Yes.
Right. Exactly. Well, okay. Another question regarding analog versus digital, then. Well, before I get to that, I wanted to mention one more thing about tubes, which is that there is some inherent difference that I understand, and correct me if I'm wrong, that tubes tend to introduce even order harmonic distortion, whereas semiconductors tend not to. Am I correct about that or not?
Yes, there are characteristics that are different in the distortions of the two devices, but you can overcome each of them with other design criteria. I have sitting in my listening room right now a hybrid tube and solid state amplifier. So it's got a tube front end and a solid state back end. And it is part of my listening rotation when I want to hear something that I thought sounded really good from a few years ago. And I have an all-tube preamp, in fact, that sometimes goes into the system to compare to. There are standards, I think, that we consider, that we've heard over our careers that we've thought have done an incredibly good job. And sometimes you got to go back to those and say, gee, what was it I liked about that? And can I get that sound another way?
Right. because my impression is that the people who like tubes, who like the sound of tube equipment, I should say, maybe are liking, they often refer to it as warm, a warm sound, which again is this even order harmonic distortion, which is the second harmonic, fourth harmonic, sixth harmonic, the even numbered harmonics. And I guess I've even heard of, for example, in the recording studio, people using tube preamps or amplifiers that then end up being digitized, but that also digitizes that warm sound. So I can see how, you know, combining the two technologies could get you to basically wherever you want to go.
Right, right. And, you know, there's even theories about how the ratios of second, fourth, sixth, et cetera, should be to each other to get particular sounds.
Well, and there are people, I'm sure, who are looking carefully into that.
There are.
Okay, well, listen, before we continue, I would like to take a moment to thank our sponsor for this episode, which is Grasshopper. Now, Grasshopper is a virtual phone system designed for entrepreneurs. Grasshopper works just like a traditional phone system, but it requires no hardware purchase or software installation. With their iOS and Android app, callers can reach you wherever you are on your mobile phone. Grasshopper allows you to keep your existing phone number so you can maintain your brand. When you make a call, your client will see your Grasshopper caller ID instead of your personal phone number. Simply select a toll-free or local number, record a custom greeting, and add multiple extensions for your business. Toll-free numbers are great for marketing and make your business sound more professional. You can set up department and employee extensions with custom call forwarding to any phone in the world. And you can get voicemails emailed to you as audio attachments. You can also send and receive SMS text messages from your business number. So join over 250,000 Grasshopper customers today. Plans start at just $12 a month, and you have a 30-day money-back guarantee. So turn your smartphone into a business line with Grasshopper. To save $50 on your order, go to trygrasshopper.com/twit. That's trygrasshopper.com/twit. And we thank Grasshopper very much for their support of Home Theater Geeks. So I wanted to touch upon some recent news with you regarding Audio Alchemy and your impending or in progress merging with Elac.
Yes, Audio Alchemy is becoming a part of the Elac group, and it's a pretty exciting time for us. As many of you who have been to trade shows where Elac and Audio Alchemy have shown together, we have achieved just amazing results. We have the common goal of high value, and that's something that, of course, Andrew Jones has been doing in his loudspeaker designs for Elac, and I've been doing with my group for Audio Alchemy. And together, I think we've astonished people with how good a system can be in a particular price range, whether it be a year and a half ago with either the B5s or B6s or Unifies, the Elac loudspeaker that was
those were the first ones introduced by
right,
Andrew. Yeah.
Right. Or more recently with the Adante speaker that was shown at the CES in January.
Right, which I heard, and I was really blown away, as was everyone I talked to about it. They heard it, and for what, $2,500 a pair for those speakers?
Right, $2,500 a pair, and maybe $6,000, $7,000 for the rest of the system. So under 10 grand for a system. Now, of course, 10 grand's a lot of money, but
it's a lot of money. I was going to say that.
A lot of money. Okay,
that is not chicken feed.
Right. But compared with what people were walking in saying they had heard in so many rooms, which was multiples of that by let's just say a ridiculously big integer.
Yeah. Sometimes an order of magnitude or more.
Yeah,
we 10.
Right. We hit it out of the park, as they say.
Oh yeah. Well, I was really amazed at that, and I know that Andrew has been using Audio Alchemy products in his demos, as you say, for the last year or two. I guess primarily for the value proposition. And he also made a point, I think, at one trade show I was at, where he was that the equipment stand he was using was, $25 from Target or something like that. Just
right.
Hey, you don't need to spend $1,000 on a cabinet, to hold your equipment to make it sound good. And he was just sounding phenomenal. So, obviously you guys, your company and Elac are well aligned in that regard. So it seems like a really good fit.
Yeah. And, something that really is going to be great for the Audio Alchemy brand in this relationship is the fact that they have scale. They're a big enough company that they can get lower manufacturing costs, lower parts costs, bigger distribution, and we can do things at prices that really we've not been able to do before, and that just improves our value proposition.
Mm-hmm. Now, you mentioned earlier, speaking of that, that you have a company that actually does some manufacturing. And I wanted to ask you about that and how that relates. I mean, Elac, I guess, is a bigger company. They do a lot of their manufacturing. I don't know where. China, maybe? It's a German company originally.
Right. They have manufacturing all over the world. All over the world.
Okay. And you've got one place where you manufacture stuff, a big variety of stuff, as it turns out.
Right. Yeah, the factory is a contract assembly company. So it is the same place that Audio Alchemy was built in the late 80s. It's exactly the same factory, many of the same people. And for small production runs, has become a really great way to build product, because we can kind of, be alongside it, help develop it, change, improve, et cetera, as it moves along. And for many of our clients,
here it's in the U.S. too.
Right. That's correct. And for many of our clients over the years, it's been where a product may have started. They get the bugs worked out, and then it's been moved to somewhere else to be made in much larger volumes.
Much larger quantities. Okay, that makes sense.
Right. So to make a few of something, you have to do it somewhere, and we have the facilities to make that happen. And we do it for other audio companies. We do video products. We do some test equipment. We do whatever comes in the door to get done. We make robotics products, kind of whatever is needed. And we've developed the skills required to make that happen.
Mm-hmm. But again, in small volumes.
That is correct.
One that brings me to sort of an aside. You mentioned to me when we were talking about doing the show that one of the things you guys make are certain parts for the photo research spectroradiometer.
I
guess that must be in fairly small volume, because how many people are going to spend $15,000-$20,000 on a spectroradiometer?
Yeah, although 10 years ago it was a lot more.
Really?
It was a pretty good volume product, because think about all the installers that were out there putting in projection TV systems and early plasmas, which were in desperate need of calibration out of the box. And, it was a pretty good business, I think, for them.
Yeah. And you're still doing it now, but I guess the volume is lower.
The volume's lower, and we made a particular product, or part of a product for them. They make other stuff, and they actually just recently moved their product out of California. So that may mean that in the future they'll find somebody else to do this kind of stuff, because we're not as convenient.
Mm-hmm. I got another question in the chat room, going back to transistors. Tinker Toy Tech is asking, what about the Carver transfer function for making transistors sound a particular way?
Couldn't tell you. Don't really know what that actually was.
Oh, okay. Must be Bob Carver.
Of course, and he's a brilliant man, so
He
I
is,
wouldn't be
he is.
surprised. Yeah.
Okay. All right. Well, I need to ask him about that.
Yeah.
In fact, he was on the show some years ago now, and I think it's past time to get him back. So I will do that.
I think if I went and looked in my closet, I probably have one of his FM tuners here still. I'm an FM tuner collector, so the TX11
Really?
TX11 was a cool product.
Let's see. Bleep Blurp is asking, I forget what was better for cartridges, diamond or sapphire? Any thoughts on that?
Well, diamonds are harder. They last longer.
Last longer. But they're not that much harder. Their diamonds are 10 on the Mohs scale. Sapphire is 9. So,
yeah, I can't think of anybody that makes that makes anything other than diamond styli in the audiophile industry. But maybe I'm wrong.
Yeah. Well, the next area I wanted to touch upon with you is high resolution audio, which I'm sure you're very familiar with. We have CDs, which have now been the sort of standard CD digital audio format for 20, 30 years now, with a resolution of 16-bit words and 44.1 kilohertz sampling rate. And now we're seeing content in 24-bit 96 kilohertz. And just wanted to get your sense of what you think of the importance of increasing the resolution beyond what CDs do.
I don't know that there's a blanket answer for that question. Like everything else, the devil's in the details, right?
All right, good. Then let's dig down into the weeds a bit, shall we?
Right. I play at shows, and of course Andrew Jones, for example, also plays at shows, 44.1 CD rips that people walk in and sit down and say, wow, that has to be high res. And conversely, I have plenty of stuff that's 24.192 and doesn't sound as good as the original CD that I also have of the same content. So you can't just make the statement that high res is better. I think that if you look at what some of the really good producers of high res are doing, they're doing it right. I think that the MQA folks, if they are able to if they can continue and do the kind of quality that they're talking about them doing, I think they'll get it right. But are you remastering the right version of the original, for example? I mean, there's so many things you can do wrong that, again,
so
you can't
points
just
in the process, that you can screw up.
Right. You can't just assume that because something is high res, it's going to be great, because there's plenty of examples where it's not.
Right. Certainly the remastering process, where have you gone back to? What were the original materials that you could get your hands on to create a high-res master?
Right.
Now, I've heard some examples. I agree with you entirely. It depends on so many things. I've heard some examples where high-res audio really did sound better, the high-res version, I should say, compared to the CD, and others where it didn't, exactly as you have said.
Right. I think it's, one of the problems with going back to some of the old masters is you really often can't get the original from which the the album that maybe we have all heard and loved was made, or the first CD was made from. It just isn't available anymore, and they'd make it from some other copy. And while it might be technically a better transfer, you may not like the performance as well. And in the end, it's all about the music, not really the technical aspects. I mean, I hate to say that on a show.
A show called Home Theater Geeks.
Right.
Yeah.
Right. But we got to geek about the right things, and playing good music is why we're doing this.
Well, that's true. No doubt about that. One other factor, though, is that with CDs, you have to have when you're recording, you start with an analog sound, typically coming from a voice or an instrument or something like that, gets put into a microphone, transmuted into an electrical signal, analog electrical signal. That ends up at some point being digitized. And if it's going to be digitized to a CD specs, you need a pretty hard filter to prevent higher frequencies from entering into the system or being encoded, because that causes all kinds of artifacts called aliasing. But with 2496, you can have a much more gradual filter. And that has been one of the things I've supposed was an advantage to high-res audio inherently.
Right. We in the early Alchemy days, we played with a product that did upsampling and then something we called resolution enhancement to take the incoming audio stream or digital audio stream and both convert it. At the time, we had 44.1. That's all we had. Converted that to 96 and also took the bit depth and interpolated it to a 24-bit depth. And to most people's ears, it was the bit interpolation that really made the difference, that the sample rate improvement really didn't do very much. But that the bit depth improvement did quite a lot. And we still use that technology in our products today. But now faster DSPs and better algorithms and all of that allows us to go up to 32 bits, which is the capability of the DAC chips that we use as converters.
And there are a couple products we have pictures of that use this technology. Remind me what they are. DDP1, I think we have a picture of, which is the Audio Alchemy DAC preamp product. That's the one. So this is a 24192 DAC with the full complement of inputs, USB and AES and Toslink and I2S, which is our proprietary digital link we use between our own boxes. But it also contains a full analog preamp. So it also has analog inputs and a real mechanical volume control that's like the knob feels like it's attached to something because it is. And that's gotten some pretty rave reviews, and it's the product that we introduced first in the new Audio Alchemy line, and sounds great. Sonic Freak in the chat room is asking, did you use different filters for the upsampled audio?
Yes. We have different filters depending on the sample rate, and of course, you change the anti-aliasing filters at the back end for DSD as well. The resolution enhancement that you're talking about, increasing the sample rate, increasing the bit depth with interpolation, leads me to think about the possible analog in video, which is frame interpolation. In video, right? And where, which is something we did.
yes, at Runco, I think, right?
Yep.
And that does sharpen the resolution or the detail of things in motion, but it also introduces an artifact that many people really hate called the soap opera effect. And so I'm wondering if there's anything like that when you upsample, so to speak, upconvert digital audio, such as you're doing.
Yeah, well, that's why we develop special digital filters that go along with this resolution enhancement that looks at those specific conditions that can create an artifact and modifies them so you don't hear them as the equivalent of what you're saying you saw in video.
Right.
Yeah. In video, we had lookup tables that under certain conditions would go say, oh, yes, if we do this kind of enhancement, we're going to have this kind of effect, and we have to mask this sub effect with a way to eliminate that artifact. Mm-hmm. We have to do something similar in digital audio.
Mm-hmm. You mentioned that people tended to find bit depth interpolation and enhancement more obvious or more audible than frequency response. Now, as you know, bit depth translates into dynamic range, and sampling frequency translates into frequency response. So are you saying, I guess you're saying then that people responded more to an increase in dynamic range than they did to an increase in high frequency response?
That's correct. Right. That's our theory as well. It's hard to judge why people interpret what they hear the way they do.
Mm-hmm. It's interesting to me that you say that. Very interesting, because as human beings, we have a certain dynamic range that we're sensitive to, which is I can't remember now. It must be in the 100, 110, 120.
110, right.
110 decibel range. And very few recordings are actually recorded with that much dynamic range. And even if they are, you have to be in a pretty quiet environment in order to even be able to hear that much dynamic range.
Yeah, you can never get the noise floor at a low enough where you could actually perceive anywhere near that kind of dynamic range. I think, maybe 60, 70 dB is the best you could do.
Mm-hmm. Which is why I find it very hilarious that some companies are touting high-res audio in their car systems. It's like, I'm sorry, you're not going to hear that in a car because the noise floor is so high, right? You're driving down the street.
Right.
Very strange.
But that may be why they play it so loud then.
Ah, well, there you go. And then there's the high frequency response. I don't know if you knew this or not. I don't remember if I mentioned this to you offline, but I did a test, an informal, unscientific test, I will admit that up front, on AVS Forum, where I put 3 songs up there. Mark Waldrop helped me. He's one of these guys who records at 2496, and he's meticulous about keeping it high res throughout the entire audio chain. And so we put up some songs from his catalog, which he graciously gave me to do this with. One of them in its native 9624. The other one, the same file, down res to 1644.1, and then back up res to 2496, so they would look the same to a computer. Mm-hmm. And I asked people, I said, and I just randomly labeled them A and B, and I said, tell me which one's high res. And I said, also tell me what system you're using to listen to it. And I found that of those who had systems that were not high-res capable, that is, they couldn't go above 20 kilohertz, they got correct hits 50% of the time, as you would expect, random. Of those who did have systems capable of reproducing higher frequencies, 80% hit rate, correct hit rate. And yet, I know for a fact that most people, certainly most adults, cannot hear even up to 20K. So what do you suppose is going on?
Interesting psychoacoustic effects, huh?
Yeah, really. Really.
The electronics can sometimes the electronics can produce frequencies above a certain number, right? We know that loudspeakers roll off, but there might be there certainly will be some output in that range. Mm-hmm. Of course, it's probably not coming out of your digital system because of the brick wall filters. Mm-hmm. So interesting.
Well, and these were digital audio files, which a lot of people played from their computers. Mm-hmm. Anyway, I found that very interesting that somehow, and people have speculated that maybe it was some distortion or maybe it was something else. We level matched the files, and so we tried to make it as fair as possible. And again, it wasn't a scientifically large enough study to really say anything statistically. It was just an informal thing of, hey, let's try this.
Right. We've all realized that the ear brain is an amazing piece of test equipment.
No kidding, man.
The problem is we don't have a good way to display the information that we gather. And the interpretation of it then becomes subject to discussion because there's no level playing field for how to present it. But there's no doubt that we hear and interpret things, and some better than others, certainly. And experience is often, a big key to being able to know that these differences exist.
Yeah. Digmax in the chat room is saying, ears become trained when hearing better systems. And that's an interesting point, isn't it? That if you have a higher quality system, over time, you're listening to it, and then you go back and hear something that's less capable. Even if you're listening to, say, CD, or God forbid, MP3, you might hear a difference. On MP3, maybe not, but
a few years ago, I did a show in LA with an audio alchemy dealer there called Can Jam, which was, of course, a headphone show. And
sure.
we went, however, showing the audio alchemy electronics on a pair of Wilson Sabrina loudspeakers. So we were one of maybe 2 or 3 rooms that weren't showing headphones. And young guys would walk in, sometimes with headphones on their head, with kind of the jack in their hand, waiting to see what they were going to plug
it into the next thing. Yeah, right.
Who we would encourage to sit down, and they'd eventually take the headphones off their head once they sat down. And
I should hope so.
You never know. It was astonishing to see their reaction because many of them had never heard a 2-channel audio system of the kind of quality we were showing, at least. And they'd even look around the room for where are the rear speakers? Well, of course, there weren't any, right? But it was a properly set up 2-channel system that sounded 3-dimensional.
Mm-hmm.
And a few of them had the right reaction, which is, wow, this is amazing. This is nothing like what I'm used to. I'm hearing so much more than I hear through my headphones.
Well, now here's
that's the training we need.
Yeah. Well, here's another whole topic of discussion, headphones versus speakers. We were talking about this a week or 2 ago, where with speakers, you have to deal with the room, right? I mean, there are acoustic effects that the room has, which with headphones you don't have. On the other hand, when you're listening to headphones, everything is in your head rather than around you. I mean, with virtualization systems notwithstanding. I'm sure you've heard headphone virtualization systems where it sounds like sound is coming from speakers outside of your head. But for the most part, you listen to headphones, it's all in here.
Right. Yeah, but then you're dealing with the acoustics of everybody's individual ear structure. And that in itself is that's just an amazing subject of its own, right?
It's got another question here. Emily the Strange is asking, is there even information or sound that would span that large of a range? We're getting back, I think, to dynamic range here, but also frequency range for that matter. And the answer is there can be, but it's actually pretty hard to capture in the first place, much less reproduce. Sure.
There are certainly test recordings that have been made for what's possible. And when if you're doing steady state tones, there are CD test discs, for example, which are probably really good at that, and getting, mathematically getting to the 96 dB limit that a CD could do.
I also wanted to just let people know that you've had your hearing tested, and it really astonished me what the result was.
Well, I have to give a lot of credit to my audiologist, actually my ENT, who I went to with a ear infection problem after flying with the flu and getting it all lodged in my station tubes. Yeah,
that's not good.
Yeah. And I challenged him and his audiologist to give me back the frequency response that I was used to, because they were perfectly happy with me being down 10 dB at 10 kilohertz, which seems to fit the average American male in my age group. And
right. And all they're really interested in, at least at the base, is whether or not you can understand speech.
Right. Intelligibility is the biggest thing for them.
Exactly.
And my goals were significantly higher. And I caused them to push their testing limits to be sure that, I was good at 16 kilohertz and in fact was within a dB at 10 kilohertz.
Within a dB of flat at 10 kilohertz.
Yeah.
And you're out to 16 pretty well too, right?
Right.
That's just
right.
astonishing. I haven't had mine done in a...
That's as good as you can do with the kind of equipment that they can get.
Right. Isn't that interesting? You have to look long and hard to find an audiologist with the equipment to be able to test up to 16 kilohertz.
Sad.
Most of them will go up to 8 or 10, and that's it. So again, because they're only interested in speech intelligibility. But we're interested in something else. We want to hear the music, and we want to hear as much of it as we can. And so I encourage everybody who is interested in knowing what their hearing profile is, at least as a baseline, so you can compare it in the future if something happens, to find an audiologist with an audiometer, which is the equipment that they use to test this, that goes up to at least 16 kilohertz. There are a few even that go to 20, but they're very rare. And most audiologists won't invest in that kind of money, in that kind of equipment, because again, as I say, they don't care about that. They care about, can you understand what your wife is saying or what your husband is saying or what your kids are saying? And if you can, then your quality of life is good enough.
If I could relate one, unfortunately somewhat disgusting fact that I got from my ENT, but
sure,
most people that come in with hearing loss, especially at high frequency, if it wasn't because they're in a rock band or something like that, is usually can be cured with a good cleaning and removing wax.
Yep. And in fact, I do that probably twice a year.
Yeah.
And I go to my ENT to do it as well. I mean, you can go, audiologists will do it, your general practitioner will do it, but I really I need my ears for my profession. And so I go to an ENT to do it. And it does help, it really does help a lot. Emily the Strange is asking a somewhat side tangential question. Is there any sign of human hearing differing across different countries or regions of the world? I don't know. Probably, I would guess that if there's someplace where there isn't a lot of ambient noise, like maybe an Inuit village or something like that, I'll bet you people have better hearing because they haven't been exposed to loud sound as we have in the industrial world. Wouldn't you think?
I would think. And of course, those people that weren't rock and roll fans in their younger years probably have an advantage as well.
Yeah. And how many of us, weren't rock and roll fans? I mean, I went to concerts. I played in bands, rock bands in college and big bands for a long time with the trumpet sitting right behind me. So I know I've got some compromises there. You must have gone to rock concerts in your youth, huh?
Of course. Yeah. I mean, there's a particular Emerson, Lake and Palmer concert that an audio buddy of mine attended with me. I think we were 16 or 17. And last I ran into him, which was at RMAF, I think, this past year, he was like, wow, do you remember that concert we went to? I'm surprised we can still hear.
Yeah, me too. I think it was 2 years ago, or maybe it was only last year. Harmon put on a concert at CES, and the artist was Kiss. And I actually took I took my sound level meter, my app in my phone, and while they were playing, the average was like 120 dBA. It was like, wow. Oh man, And I had my earplugs in. I have custom earplugs. I try to protect my hearing, and I recommend that everybody do that. But man, that was just over the top.
There was a Monster Cable Chicago concert a few years ago that we went to at CES, and it was so loud that everybody was, everyone who had the great tables up in front were moving to the back and just staying away. It was between, you take a band like that has a lot of onstage energy anyway, then you add, a sound system that they brought, and plus what was in the venue, it was unbelievably loud.
Well, the last thing I wanted to ask you about is another very important thing with regard to digital audio, and that is jitter. And we hear this term bandied about quite a bit, but I'd love for you to give us an overview of what it is, why it's bad, and how to get rid of it.
It's funny, when I started going to trade shows again for Audio Alchemy, the new Audio Alchemy, consumers would come up and say, I had one of your jitter filters that you made in your earlier days, and thank you for inventing jitter. Well, we didn't. They kind of got it backwards there. What we did back in the day was that we discovered its effect on audio, and we made a product that helped fix it. And it was an outboard device. You have a picture of one, I think, an old one called DTI. And it was basically a reclocking device that put a better clock in place of the in place of the incoming clock on the, that's the guy. In place of the incoming clock inherent in the SPDIF stream.
Right.
And
so just to make sure everybody understands that, digital audio consists of a stream of zeros and ones, basically, two different voltages on a wire, and exactly how those are timed and how they're spit out, where they're going, depends on a clock. There's a clock that's internal that's ticking away and telling the stream when to send each bit. Have I got that right?
Right, and it's ticking away quite quickly.
Yes.
And if the actual speed of that clock was wrong, then the music would play faster or slower, depending on which direction. And there were CD players back in the day, the early days of all this, when people were modifying players to make them better, where they were actually changing the clock frequency slightly to alter the speed, so the pitch of the audio coming out was a little different than intended. That was an odd trick that a few people were playing.
But they wanted that. They wanted the pitch to change.
They wanted that. Yeah, they wanted that.
How odd.
Yeah. Anyway,
okay.
but that's the absolute speed. If the clock speed was correct, but occasionally one bit drifted slightly up or down, if it didn't stay precisely at that exact clock rate, that's called jitter, or sometimes known as phase noise. And that's where the ear is incredibly sensitive to a particular distortion that type of clock error can create. And that's something that we kind of figured out. It wasn't a unique problem. It just that it's the first time it had existed in audio. It's
natural in digital audio systems that unless they're really, really calibrated highly, you're going to get some amount of inaccuracy, right? Right. And clocks, to be the kind of quiet that we're talking about, they need to operate in a stable temperature environment. So that product that you just showed, the DTI, had a clock called an OCXO, an oven-controlled crystal oscillator. So we actually had the little piece of quartz that was vibrating at the specific frequency in a temperature-controlled environment. And that can get particularly crazy. I mean, there were people at the time making atomic clocks that were rack-mounted devices that just supplied the clock that your audio system was supposed to be synchronized to.
kind of over the top. But if you're a recording studio, that makes a big difference. You want all of your equipment to have a very low jitter clock, and you want it all to be synchronized so that every digital device that you're passing the music through is sort of beating to the same heart, which keeps a particular kind of distortion that can crop up in digital systems. It keeps it down by making sure the clocks don't beat against each other and come up with oddball timings and stuff. Anyway, so this jitter phenomenon is something that we learned to control, both through external devices and then in CD players that we made, and then in DACs that we came up with that had these highly precise clocks inside them. And we weren't the only ones. There were other people doing it. And of course, now it's much more common. But it is kind of one of the issues that people forget a little bit and now are rediscovering with the advent of media players and devices that play files. And it all matters. The most important thing people have to remember with playing back these kind of things is everything matters. Just because
not just the clock, not just one particular component, they all have to work together.
Right. I mean, you may have some high-speed, i7 overclock computer as your music source, but it may not sound good because there's all kinds of issues in that digital output that's feeding your DAC, and the combination just doesn't work.
Yeah. Gary and Jax would like to hear an explanation of exactly what a DAC actually does.
DAC. So a DAC, DAC stands for digital to analog converter. So it is the device or the product or the chip, depending on what level examination we're talking about here, that takes the streams of ones and zeros that come in from your digital source, whether it be a CD or an MP3 player or something off your computer, and converts those digital bits back into the analog music that we all know and love.
That's all it is. That's all there is to it. And of course, as you say, there are several pieces of the signal path through a DAC, any one of which can affect the ultimate sound quality that you hear. Right.
And, if you take those letters and flip them around and you come up with ADC, you have analog to digital converters. And that's the side of the equation used at the recording end of things that takes the precious little microphone signals that get picked up from the music source and turn them into the digital bits that ultimately we reconvert back into analog.
Right. And so there's another set of points in a signal chain where things can go right or wrong.
Right. Sometimes it's amazing that we get music at all out of all this.
Really. Now, speaking of digital to analog, one of the arguments for CDs are plenty fine is that, according to the Nyquist theorem, which kind of deals with all this stuff, it is theoretically possible to perfectly reconstruct a sequence of bits into the waveform that originally generated them. When you look at the waveform of a digital signal, it looks like it's got a bunch of stair steps in it. And the question is, can those stair steps be smoothed out so that the resulting analog waveform is exactly the same as what came in the ADC at the other end? And the Nyquist theorem says that's at least theoretically possible.
Theoretically, yes. Difference between, theory and practice.
As you say, the devil...
Right, devil's in the details. There's an article out there circulating or was circulating in the audio industry called, or just says Nyquist was wrong.
Really?
And,
Oh, I'll have to go look for that. Well,
if he was, if we assumed that he was right, then what do we need anything other than 4416, right?
Exactly.
Right.
Well, that's been a big part of our conversation today, which sadly must come to an end. We've had a great time talking about all kinds of stuff, and I want to thank you so much for being here.
Thank you, Scott. Appreciate it. Thanks, everybody that has been listening today, and to your sponsor. Appreciate it very much.
You bet. That's Peter Madnick. He is the chief alchemist at Audio Alchemy. And you can find out much more about the products that they make at audioalchemy.com and, of course, at elac.com now that those two companies are merging together. You can always find me at avsforum.com. You can email me at scott@twit.tv, and you can follow me on Twitter at htgeekscott and at avsforum. You can always find previous episodes of Home Theater Geeks right here at twit.tv/htg and on our YouTube channel, youtube.com/twit Home Theater Geeks. Next week, my guest geeks are going to be several people who attended the Hollywood Professionals Association, or HPA, Tech Retreat, which is still happening this week, which is why we're not talking about it today, but we're going to talk about it next week, because there's always really interesting technical, geeky stuff that goes on at that show. So I do hope you will join us for that. Until then, geek out.